Good morning. In today's session, we will learn about a phenomenon of light called polarization. Hope you all have studied about various other phenomena of light like interference, diffraction, etc. So, one such phenomenon is polarization. This phenomenon actually establishes the transverse nature of light waves. You all know that light waves are transverse in nature. So, this phenomenon of polarization actually establishes the transverse nature of light waves. Now, let us demonstrate the phenomenon of polarization with the help of an example. See, here you can see a string or a rope named AB. One end of the rope is fixed at the end B, whereas the end A is free. Now at that free end, suppose that you are moving that string up and down. So when you're doing like that, you are actually creating transverse waves. Now these waves actually travels or propagates through the slits S1 and S2 only if S1 and S2 are parallel to each other as shown in figure A. Okay, but the waves will not propagate through S2 as shown in figure B if S1 and S2 are uh, perpendicular to each other, which is shown in figure B. So the waves thus produced will travel through the slits S1 and S2 only if the slits S1 and S2 are parallel to each other as shown in figure A. But if the slits S1 and S2 are at right angles to each other as shown in figure B, then the light waves will not propagate along S2. Okay, now if you are moving that string at the end A in a circular manner, definitely waves will be in the circular motion, and it will show only linear vibrations parallel to slit S1 because S1 will stop all the other components. If S1 and S2 are at right angles to each other, then the rope will not show any vibration beyond S2. If you are producing longitudinal waves, that is, if you are moving this if you move the string up and down, you are creating transverse waves. Now if you want to produce longitudinal waves, then you have to move the string backward and forward. Now if such longitudinal waves are produced, then the waves will pass through S1 and S2 irrespective of their position. Now similar is the situation with the light waves also. See the figure. You can see S, that is here you can see a source. Here that source actually produces ordinary light, that is unpolarized light. Okay, that is particles vibrate in all directions. See, when such an ordinary light or unpolarized light with that means unpolarized light means particles vibrate in all directions. So when such a light is passed through a tourmaline crystal, say A, then the light that emerges from that crystal A will be plane polarized. Plane polarized means vibration of particles are confined to a plane. Now you are again passing that plane polarized light through another tourmaline crystal, say B, and after the light emerging from that B will be of maximum intensity only if A and B are parallel to each other as shown in this figure, whereas the emergent light will be of zero intensity if these two crystals A and B are at right angles to each other as shown in this figure. Okay, so the emergent light will be of maximum intensity only if the crystals A and B are parallel to each other, and they will be of zero intensity when A and B are at right angles to each other. Now that crystal A is called polarizer and the crystal B is called analyzer. Okay, now what is unpolarized light? Means in that light particles vibrate in all directions. What is a plane polarized light? That is, all the vibrations are confined to a plane. Now that is what written in this paragraph. Okay, so here you get two definitions. Now this experiment actually proves the transverse nature of light waves. So if you are asked an essay question like prove the transverse nature of light waves, then you can demonstrate this example. Okay, so what is unpolarized light? In unpolarized light, all particles vibrate in all directions. Okay, where what is polarized light? In polarized light, all the vibrations are confined to a plane. Now here again you will get a definition, that is, what is plane of polarization and what is plane of vibration. Okay, now just read it. when ordinary light is passed through a tourmaline crystal, as I said before, light is polarized and the vibrations are confined only in one direction, perpendicular to direction of propagation, and that plane polarized light, that light is plane said to be plane polarized, and the plane of polarization is that plane in which no vibrations occur. In the figure, it is represented by the plane ABCD. Okay, now the vibrations occur at right angles to the plane of polarization, and the plane in which vibrations occur is known as plane of vibration. It is represented by the plane EFGH in the figure. So from here you have to study two definitions, that is, what is plane of polarization, next one, what is plane of vibration. See, these are the various types of representation. The first one actually shows unpolarized light, that is, particles vibrate in all directions. The second one also represents the same. Now the last one actually represents the plane polarized light, that is, the vibrations of particles are confined to a plane. Now polarization can be produced by various aspects. Now today we will learn about polarization by reflection and then polarization by refraction. Now polarization of light by reflection from glass surface was first discovered by a scientist called Malus in 1808. He observed that polarized light is obtained when ordinary light is reflected by a plain sheet of glass. Now just consider the figure, that is, light is incident along the path AB on glass surface. Light is reflected along BC, which is very clear from this figure. Now in the path of BC, you are placing a tourmaline crystal and you are just rotating that crystal slowly, and when doing so you will observe that light is completely extinguished, that is, light completely disappears at a particular angle of incidence. That angle of incidence is called polarizing angle. Okay, so here another definition is define polarizing angle, that is, polarizing angle is that angle of incidence for which polarization of reflected light is maximum. Its value is 57.5 degree for glass surface. Now this production of polarized light by glass surface can be explained as follows, that is, the vibration of incident light is resolved into two components, one parallel and the other one perpendicular to glass surface. Parallel component is reflected whereas perpendicular component is transmitted. Now another important section is Brewster's law. Here you will get a definition, what is angle of polarization. Okay, Brewster, in 1811 he observed that when ordinary light is completely polarized in plane of incidence, when it gets reflected from a transparent medium at a particular angle, that angle is known as angle of polarization. Now Brewster's law states that tangent of angle of polarization is numerically equal to refractive index of the medium. It is given by mu equal to tan I. I is the polarizing angle, mu is the refractive index of the medium. Now its proof, that is, an unpolarized light is incident at an angle equal to polarizing angle on a glass surface. It is reflected along BC as shown in this figure and refracted along BD. Now from Snell's law, you know refractive index mu is equal to sin I by sin R. I is the angle of incidence, R is the angle of refraction. Whereas from Brewster's law, you know mu is equal to tan I. Tan I is again equal to sin I by cos I. So comparing 2 and 3, you get cos I equal to sin R. Now sin R is nothing but cos 90 minus r. So from that you can write I plus r equal to 90, that is, refracted and reflected rays are mutually perpendicular to each other. So that is a proof. Okay, prove that refracted and reflected rays are mutually perpendicular to each other. Then you will get another definition, state Brewster's law, define angle of polarization, etc. So these are important. That is, refractive index is of the substance actually varies with wavelength. Okay, so similarly polarizing angle will also be different for lights of different wavelength. Okay, here in the figure, in the reflected beam, the vibrations that are that are parallel to the plane of incidence cannot be observed, but whereas vibrations that are perpendicular to the plane of incidence actually contributes to the resultant intensity. Okay, so that is why we are getting plane polarized light along BC. Now the refracted ray in this case has got two types of vibrations, one in the plane of incidence and the other one at perpendicular to the plane of incidence. Okay, Now the other one is, so this is about polarization by reflection. Next is polarization by refraction. Okay, suppose that you are having a glass surface. Now reflection from a single glass plate will be very small percentage. It will be a very small percentage. Okay, so if you are using more and more glass plates, more and more reflection will you will get. Okay, so if you are using a pile of plates or a collection of plates, then you will be able to produce plain polarized light. That is written in the first paragraph. That is, now we are going to see how polarization is produced by refraction, that is by using a pile of plates. Here, if we use a pile of plates and a beam of ordinary light is incident at the polarizing angle on the pile of plates, then what happens? Some vibrations perpendicular to the plane of incidence will be reflected by the first plate and the rest will be transmitted through it. Now, when this beam of light is incident on the second plate, what happens? Again, some of the vibrations perpendicular to the plane of incidence will be reflected and the rest will be transmitted. This is how you produce polarization by refraction, that is by using pile of plates. Now this process continues, and that is, if you are using 15 or 20 plates, then the transmitted light is completely free from vibrations and is completely free from vibrations at right angles to the plane of incidence. That is, it is having vibrations only parallel to the plane of incidence. So we get plain polarized light by refraction with the help of pile of plates. That is, the arrangement is shown in this figure. So what is pile of plates? It is nothing but it consists of a number of glass plates, one kept on the other. That is, it is supported in a tube, and each of these glass plates are inclined at an angle 32.5 degree to the axis of the tube. Then a monochromatic light is allowed to fall on the pile of plates at polarizing angle. Then the transmitted light will be polarized perpendicular to plane of incidence, and the intensity can be examined by a similar pile of plates which work as an analyzer. So this is how polarization is produced by refraction. So this session is very important, that is polarization by reflection and polarization by refraction. That is, how will you produce polarization by refraction? By using pile of plates. So just explain what is meant by pile of plates, the experimental setup, and then how you are getting plain polarized light using pile of plates or by refraction. These are two just notes. If light is polarized perpendicular to plane of incidence, it means that vibrations are in the plane of incidence. Now if it is polarized in the plane of incidence, that is, if it is polarized parallel to the plane of incidence, then it means vibrations are perpendicular to the plane of incidence. Okay, so for today's session, this is enough. Thank you.